Welcome to the physics class. BSc Physics 3rd semester. Paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In Unit 3, in this paper, Theory of Dielectrics and Moving Coil Calorimeter. In the third session, we learnt about the dielectrics in an electric field. First, dielectrics in an electric field. We now seen that the first example. In this case, the dipoles will be obtained in the presence of and absence of an electric field. How it can be looked like this. So, without field, dielectrics are obtained like random arrangement. They are random orientation between the polars. And after the application of the electric field, the positive charges will be aligned in the direction of the forward external electric field, and negative charges will be obtained in the opposite direction. These two charges separated by a small distance, it will be dipoles, are obtained in the presence of the electric field. So, in case of now in second diagram, this shows us in polar and non-polar molecules in the presence and in the absence of electric field, how it can be aligned. First we seen polar and non-polar versus non-polar dielectrics. So in the absence of external electric field, polar dielectric molecules are randomly oriented with a zero net dipole moment, while non-polar molecules have also zero net dipole moment. In the both cases, dipole moments in the absence of electric field is zero. Their randomly arrangement of the atoms will be obtained, or dipoles are randomly arranged in the absence of electric field. So now we apply to the external electric field to the both polar and the non-polar molecules. What happens? Now we see then the external electric field is applied to the polar molecules. Individual dipole moments tend to align with the field. It means dipole moments after the application of the electric field, it will be arranged in the direction of the electric field. When summed over all the molecules, there appears some net dipole moment in the direction of the electric field, that is, dielectric is polarized. In case of the polar molecules, after the application of the electric field, all the dipoles, they are orderly arranged in the direction of the electric field. It means dielectrics gets polarized. Next, now we see into the non-polar dielectrics. Then the non-polar dielectrics in the presence of what? External electric field. So, in the presence of external electric field, E naught, the center of positive charges in the each molecule pulled in the direction of E naught. Here we can see that the positive charges are pulled in the direction of the applied electric field, and negative charge is pulled in the direction opposite to that electric field. Thus means two centers of the positive and negative charges of the molecules separated. Thus means the distance between these two positive and the negative charges will be obtained. These molecules get distorted and is said to be a polarized. A tiny dipole moment will be obtained in case of non-polar molecules in the presence of external electric field. Suppose when a dielectric slab material is placed into the uniform Suppose a slab of dielectric material is placed into an uniform electric field E naught. It means uniform electric field will be applied into the forward direction. It will be placed into the two parallel plates of the capacitor. They will be charged. This slab becomes electrically polarized. The polarization inside of the body of the dielectric material is cancels each other because negative side of the one of the polarized molecule adjacent to the positive side of the positive side of its neighbor. Thus, the net charge of the interior slab remains 0. This changes hence dielectric do not cancel. This means positive charge and the negative charges, it will be adjacent to each other, it will be cancelled, but total dielectric moment or net dipole moment do not cancel each other in dielectric material. The polarization, it will be changes induced on the two faces of the slab. The polarization, it will be induces on the both sides of the slab. Both sides of the slab produces own electric field, that is E dash. Polarization will be produces to the electric field in the direction opposite to the electric field. Applied electric field direction like this direction, polarized direction, electric field will be obtained this direction, that is represented by E dash. So, which opposes the external electric field. Hence, the resultant electric field P in E will be obtained within a dielectric is smaller compared to E naught. So, but the points are in the same direction as the E naught, but the points are obtained into the resultant electric field will be obtained in the direction of the electric field. Therefore, we can conclude that dielectric is placed in an electric field. Within an electric field, dielectric will be weakened. Dielectric will be weakened or reduces. So, therefore, how much it will be reduction? The reduction of the magnitude of the electric field, applied electric field is E naught. It will be changes to the final resultant electric field is E, causes the reduction of the potential differences between the plates of the capacitor. V initial potential will be V naught, and after the final it will be changes into the V. Let V naught and V be the potential differences without dielectric, and dielectric completely filling with the space between the plates. And then the ratio of E naught to the E, initial electric field, external electric field to the resultant electric field, which is equals to the V naught dividing by V. V naught dividing by V, which is also we know that C dividing by C naught, that gives the dielectric constant of that material. K is the dielectric constant of that given dielectric slab. So finally, dielectric slab, which is a dielectric constant, which is equals to the ratio of E naught to the E in terms of E applied external field, in terms of potential V naught dividing by, in terms of capacitance C dividing by C naught, that is equals to K. The K is known as an dielectric constant of the slab. This is represents the electric field within a dielectric is reduced by a factor K. Thanks for watching this session.